Hey guys! In this video, I'm going to go over how to add and subtract rational functions. And there's 4 steps. You want to factor the numerators and denominators. We're going to find our least common denominator. Then we're going to rewrite all of our fractions with the common denominator. And in order to do that, we're going to multiply the numerators by any of our missing common denominator factors. And then we can add and subtract across. Now, mind you, when we're doing these operations on rational functions, it's just like our operations on fractions. So I'll give you an example just from a fractions standpoint. If we had 2/3 and we were trying to add 3/4 to this, okay, we need a common denominator. And the least common denominator between 3 and 4 is 12. So say we rewrote all of these fractions over our common denominator 12. We're going to need to multiply the numerator by a factor that got us to 12. So in order to get 3 to 12, we needed to multiply it by 4. So we want to multiply the top by 4. In order to get 4 to 12, we need to multiply it by 3, which gives us 8 plus 9. So we get 17 over 12. Okay, so we're doing this same operation, but now we're going to add some x's to it. It's really no big deal. So looking at this example, remember the first step is to factor the top and bottom. And x plus 2, x minus 7 are already factored. So we're going to start with this x squared plus 4x minus 12, and we're going to factor that. And we're going to factor this bottom one. Now, in order to factor the top, I'm going to say that that is going to be the diamond method because, one, there's no coefficient in front of the x squared. It's just a 1, and there's no x on the 12. So I know that there's probably not a GCF. And then we have a times c on top, which is negative 12, and a 4 on bottom with the ax on top. So we're looking for two numbers that multiply to get negative 12 and add to get 4. And I know that 6 and 2 multiply to get 12, and there's a 4 difference between those two numbers. So if I make the 6 positive and the 2 negative, that's going to give me my 4 that I'm looking for. So those two parentheses are going to be x plus 6, x minus 2. Now, in order to factor the bottom, I'm going to say the same thing, going straight into the diamond method. There's no number in front of x squared, and there's no x on 21. So we have negative 21 and negative 4. We have ax on top. And I know 7 and 3 multiply to get 21, and the difference between 7 and 3 is 4. So if I make the 7 negative and the 3 positive, that's going to give me my negative 4 that I need. So we have x minus 7 and x plus 3. So now we're going to rewrite both of these fractions in their factored form. So we have x plus 2 over x minus 7 minus x plus 6, x minus 2 on top, x minus 7, x plus 3 on the bottom. Okay, now we need a common denominator. And I always say if you have a pair, you're only going to write it once. And we're looking at all the factors on the bottom of your fractions, so in the denominators. So first up, I see we have an x minus 7 here and here. So I'm going to write x minus 7 one time for our common denominator. And then the only thing I'm missing right now is an x plus 3, so I'm going to just write that next to my x minus 7. Okay, now we're going to rewrite all of these fractions. We have an x plus 2 minus x plus 6, x minus 2 over our common denominator. I'm going to cheat a little bit here and copy this one. Okay, so now that we have our common denominator, we need to multiply the top by the missing factors. So starting with this first fraction, notice we have an x minus 7 in our original fraction and we have an x minus 7 here. We did not have an x plus 3. So in order to keep the fraction the same, we need to multiply the top by x plus 3. And on this second fraction here, notice we had an x minus 7 and an x plus 3. So we didn't change that fraction at all. Now, in order to subtract, we're going to subtract across the top. So the x plus 2, x plus 3 stays the same. And this is going to be minus x plus 6, x minus 2, all over our common denominator, which was x minus 7, x plus 3. Okay, so we could multiply those out and combine like terms, but I'm going to stop here on this step. Now we have our rational in over a common denominator. So let's go ahead and look at this next example here where we're adding them. Okay, so same thing. We want to factor the tops, factor the bottoms of anything that can be factored. So x minus 4 and x minus 1 are already factored. So we only need to look at this x squared plus 5x plus 6, and we need to look at this x squared minus 4. So for this first one, I'm going to say that's the diamond method. There's 3 terms, there's no number in front of x squared, and there's no x on 6. So we have a 6 on top, a 5 on bottom, and an ax. Now, I know 2 and 3 multiply to get 6, and they add to get 5. So those are going to be my side numbers, giving me x plus 2, x plus 3. And for this second denominator, I'm going to say x squared minus 4 is the difference of squares. So if I took the square root of x squared, I'm going to get x. And if I took the square root of 4, I'm going to get 2. So my 2 parentheses are going to be x plus 2, x minus 2. Now we're going to use those factors to create a common denominator. And we're only going to list our pairs once. So I'm going to start by looking for my pairs. Notice I have an x plus 2 here and here. So I'm going to write that once. Then I have 1x minus 2. And then I have 1x plus 3. Okay. So we're going to rewrite all of our fractions over this common denominator. And there was a plus in the middle. So we have this one, and we have this one. On top of that first fraction, I had an x minus 4. Now let's look and see what we were missing. So we have an x plus 2 here. We have an x plus 3 here. We do not have this x minus 2. So that's what we need to multiply the top by. And then for this second fraction, we started with an x minus 1 up top. And then I had an x plus 2. I had an x minus 2. I did not have an x plus 3. So I'm going to multiply the top by x plus 3. Okay, and now that we have a common denominator, we can add across the top. So we're just going to write the fraction all over x plus 2, x minus 2, x plus 3 with our x minus 4 times x minus 2 plus x minus 1, x plus 3. Now I would distribute the top, or you guys can use the box method. So we're doing x times x, x times -2, and then we're doing -4 times x, -4 times -2. And we're doing that to both of them, and then you would collect like terms on the top. But again, I'm going to stop there on this question. I'm going to ask you guys to try this one. Go ahead and pause the video. I'm going to put up the answer. So this is what I got for the answer. I hope you got it.